Okay, so today we're looking at experiment 1, subtractive color mixing, and this is part 3. And we will look at yellow, magenta, and cyan dye using the UV-Vis spectrophotometer. So the first thing that we need to do is to take to calibrate the machine with a solvent that was used in our solution, and our solvent is water. So you would experiment, calibrate. We'll skip warm up because that's already warmed up, and we will say finish calibration. And okay, so if we look at our data sheet, you will see that the first color, ink that we're looking at, or we should look at, is yellow. So here I have a container of yellow ink that I've placed in this cuvette. And this cuvette, we have two frosted sides and a clear side that the light would go through. So I would place this here. We have to make sure that we've cleaned this surface and there is no fingerprint on the sides, and then I would say collect. Okay, so depending on the concentration of the solution, the absorbance peak will vary. So we see that there's a peak at absorbance, so this is absorbance versus wavelength, and we see that we have an absorbance peak in the blue region. So in your data sheet, you should record what region you're seeing an absorbance peak. And this would mean that the other region, the green region and the red region, would be the region where you're reflecting light. So that should be filled in on the end column. The next ink that we will look at is magenta ink. And I've placed this in the cuvette. And again, we're placing it in such a way that the light will go through the non-frosted side. And here we will see an absorption peak now in the green region. So on your data sheet, you will fill in absorption region. The second column, you would have a green or magenta, which will mean that reflection is occurring in the blue and the red region. And we have cyan ink, again, in the cuvette. So we saw earlier absorption in the blue region, in the green region. So I'm sure you can guess what region we should see an absorption peak here. And this should be red. So this entire spectrum is divided into 3 main groups: the red, the green, and the blue. So although you're seeing this peak in the yellow, this is considered a red region. Okay, so now let's take a look at the mixtures. Okay, so here we have magenta ink and yellow ink, and we saw that the magenta showed an absorption peak in the green region, and the yellow ink showed an absorption in the blue region. If I mix these two, it'll be a mixture, and I should still see those two absorption peak. Along with that, you will notice a color change, right? What do you see now? You see that the solution is now red. And the reason for this is because it's now reflecting red light. We clearly do not see a peak in the red region, and that's because that's the region where the light is being reflected. Hence, we're seeing that the mixture looks red. So now we're mixing the yellow and the cyan, and we remember earlier we saw an absorption peak for yellow in the blue region and an absorption peak for the cyan in the red region. So let's see, when we mix these two, we see the resulting color, and I'm just going to tilt this a little. It still looks a little cyan, right? Does it look green? Okay, it could be a little greener, and that, so what do we see here? We see an absorption peak in the red region and an absorption peak in the blue region, but we do not see anything in the green region. And that's the reason why we see this as green, because that's the light that's being reflected into our eyes. Okay, so now we're mixing cyan, which shows an absorption peak in the red region, and magenta, which shows an absorption peak in the green region. So when I mix these two, I see a clear blue solution, and that's because blue light is being reflected to us. So if I place this in here, I should not see a peak in the blue region, and that's because this is representing what light is being absorbed, right? Because we're plotting absorbance here. So we are seeing a blue solution or blue mixture here, because we have blue light being reflected. Hence, we do not see a peak in the absorption plot.